Okay, let's go. So, hello everyone. I'm super grateful for everybody who came on time for that you decided to spend next 30 minutes with me discussing super important topic, which, in my opinion, is very popular among engineers and not very popular among managers. While I think it should be the other way around, because what I'm going to prove today, I hope to prove it today, that platform engineering is in fact more a topic for managers than for engineers, even if the engineering is in a name. So today's agenda looks like this. I will guide you through the idea why this is important for managers as well. We will start on how platform engineering is different than DevOps and what does as a service mean in platform engineering. We'll also discuss how to properly approach the platform initiative as management, as IT management, and how to measure if we succeeded with this initiative, not only tactically but also strategically, if we delivered the value to the organization. And we'll end up with some success factors, which tells us if we actually delivered this value. And at the end, we'll quickly review a topic which may be surprising, because some of you on the meeting probably think that you have a platform in your organization. So we will check if you have a platform in your organization with a few factors. Because spoiler alert, you can have all the DevOps tools automated in your company. You can have a portal for developers. And in my opinion, you may not still have a platform. Okay, so before we start, I'll quickly introduce myself. Who am I? My name is Krzysztof Hałasa. You can call me Chris. It's easier. Last decade, I played multiple roles in IT. I started as a software developer, then I was the architect, and I ended up as a platform manager, which I am since 2022. So actually before platform engineering was that popular. I've built several internal developer platforms in the managerial role, and I also advise within IT management and operating models to large companies. Recently, I'm also team topologies advocate. I'm Polish platform engineering community leader and meetup organizer. And privately, maybe I do not look like this, but I am a fan of history, and I'm especially within military operations. So I will start our platform engineering discussion with one historical example. In 1972, there was a conflict between Israeli and Arab forces, widely known as Yom Kippur War. Israel and Arabic countries were using very similar gear, a mix of Soviet and American and domestic armored vehicles, artillery units, combat aircraft. So basically very similar and very comparable gear on the battlefield. Arab forces were 2 times bigger than Israeli forces, and yet Israel militarily won this conflict. Maybe not politically, but militarily they overcame the Arab forces. What they did differently, they simply used the gear that Israeli had, more efficiently. It was working as a one integrated system, and also they use the terrain and maneuverability of their smaller units as a tactical advantage. So Yom Kippur War is known as one of many examples in military history where doctrine and tactics overcame the gear and overcame the material parity. And it's being studied on military universities ever since the war ended. And I mentioned Yom Kippur War at the beginning because I see a lot of similarities on how companies invest in DevSecOps tools and how they operate it and how they manage their DevOps engineers. Not always thinking about efficiency in overall process in such an investment. 2 years ago, I had the pleasure to work for 2 banks. One is in Ukraine, I will call it an Alpha Bank, and second in Poland, I will call it a Beta Bank. Those 2 banks had been in a very similar place when I worked with them. They just transformed into a Spotify model, and there was a lot of new teams and new delivery coming to the organization. And each new initiative, even the old initiative or the old initiative, but with the new business requirements, new business ideas, were about to be built in a new way by the domain teams in the Spotify model and using microservice architecture. Both both banks had very similar technology setup. Infrastructure was automated, they were running Kubernetes on-prem. And yet, Beta Bank needed 3 months to onboard a new team coming to the organization compared to 15 minutes in Alpha Bank. And the time to market for new application delivery from 0 to production was two and a half times longer in Beta Bank compared to Alpha Bank. And all this Alpha Bank achieved using 5 times less DevOps engineers per developer compared to the Alpha Bank. What happened to work in military conflicts, that's why I mentioned Yom Kippur War, works also in IT, where I think that operating model, which is our doctrine and tactics, defines the efficiency of our company, not the tools we use, so not the material parity. The only difference between those two banks was this operating model, because Alpha Bank adopted platform engineering principles. Okay, so what is platform engineering? I have selected 2 definitions. The first is more about why, coming from Circus CI, and second is more about how, coming from Gartner. So why we do platforms? We do platforms to enhance developer productivity by reducing complexity of software delivery and operations. How we do it? We simplify the software delivery and operations for them, offering right capabilities so the developers focus on business value delivery instead of fighting the elements of this process or tools in this process. I like personally more the Gartner definition because they named this fighting, the struggle, a cognitive load reduction. And this term goes directly from my favorite definition of key aspects of platform engineering, key principles, and those are coming from team topologies. So for those who are not familiar with the team topologies concept, we have stream-aligned teams, platform teams, complicated subsystem teams, and enabling teams in a company. And the best way to explain what platform engineering is to focus on those 2, on stream-aligned teams and on platform teams. So according to team topologies, stream-aligned teams need to focus only on the business value streams. If we talk about applications, their primary focus is to deliver and operate the application business features, because this delivers the value then. Platform has to simplify everything else. So the stream-aligned team can focus on their job. Simplify means provide right capability and do it as a service. Easy to utilize by stream-aligned teams without any overheads. We can say that platform team is creating a system to build and operate other systems, business applications, as a service. So let's establish a common understanding what that means. As a service usually means that we have 2 parties, a service provider and a service consumer, in our case, stream-aligned team and a platform team. Those 2 parties have agreed channel where stream-aligned team provides inputs and expects agreed outcomes. And those inputs are easy to gather by stream-aligned team, focus on their true need, expressing the need, and is understandable by the stream-aligned team so they can easily provide those inputs. In simple words, a service we use, stream-aligned team use from the platform team is as simple as ordering pizza for them. We just select the pizza type, we select our address, and that's all, the pizza arrives. We don't inform the cook how to bake the pizza, how to make a cake. Remember this definition because this is the part where so-called platform usually fails, especially the comprehensive outcome, because the comprehensive outcome needs to fulfill the need end to end. This is also the part where the Beta Bank I mentioned failed or lost, were worse than Alpha Bank, and this is now I'm going to explain why it was like that. So let's start with how classic DevOps is different than platform engineering, or is it really different? Okay, so we'll start with famous you design it, you build it, you run it sentence in the classic DevOps, which started all of the DevOps and is very popular. So platform engineering is also about it, but it's focused on scaling this approach, making it efficient even if we have dozens, hundreds of DevOps teams running in the organization. Classic DevOps is also about software delivery and operation automation. We do it as well in platform engineering, but we focus this automation on reducing cognitive load to the delivery teams. So we automate not only to reduce human errors, not only because it's right, not only to have the efficiency within the tooling, but also to save developers time and simplify the DevSecOps tools for the developers. And lastly, DevOps is about resilience, scalability, and availability. Platform engineering as well is about it, but it focus on overall teams and efficiency, not just on the technical capabilities. So in short, we can say that platform engineering is nothing more than classic DevOps, but scaled. And the tricky part about platform is this one: where to put the boundary in you design it, to build it, to run it. So what does it really mean? My experience tells me that it means that different kind of responsibilities, and if you ask different kind of people, different kind of teams, most of us will agree that teams should not build and operate the building where the servers are there. Most of us will also agree that teams should take care of application business strategy, application business value, and application logic and application operations. But what is in between those layers can be interpreted differently if you ask different people. Should an application team handle own deployments and observability tooling? Should they handle own environments and security, or maybe even handle containerization, virtualization, and managed infrastructure? And while this answer can be simple for a small company, where managing all of this is not super costly for each team specifically and separately, in large companies, we can end up with hundreds of DevSecOps tools and approaches if we put this boundary too low. And those capabilities will be doing the same thing, which is handling software delivery and operations. Hundreds of tools doing the same. And this does not sound very well from the scaling perspective. And this is where also the mentioned beta bank failed, in my opinion. So let's go to this example. In beta bank, different teams were handling different areas in this cake. And every domain team was composed with developers and DevOps engineers working together. Technical teams were responsible for SDLC tools, those blue ones. And in order to get access or space within the tools the teams were operating, our domain team needed DevOps engineer to gather all necessary tooling, provide them with right information, and integrate into one working runtime environment for the application the domain team were building. So in simple words, DevOps engineer was necessary because in the tech teams needed to be told specifically capability by capability what the domain team needs, and requested in a form designed to this tool and designed by those blue teams. So how the onboarding looked like in practice? New domain team were coming to the organization. They had short deadline for application delivery, and they were eager to deliver this new business features. In order to start doing that, they needed resources. They needed delivery tools, observability tools, and runtime. And here their journey begins. So DevOps engineer in this team were putting Jira ticket to admins team for Kubernetes namespace or Kubernetes cluster. So for the runtime. Then for the database, they went to the database team and also provided a ticket. And once they did, DevOps engineer needed to contact network team to make connection between runtime and database. Then it goes to the observability tooling. DevOps engineer went to the ops team, and again, network team for connectivity, and so on and so on. So being this domain team, the journey took from up to 3 months, depending on how busy were the teams, because all the tools which was given needed then to be integrated within the pipeline, and application templates. So observability has connection to has right agents in an application. All of this had been done by the DevOps engineer in the domain team. Also, each team coming to the company, they had very similar path to follow. So in the domain team, in order to start delivery, they need to fulfill this path. They need to create and maintain the tools which were not covered in this path, like QA tooling and specific authorization tools. And besides, they were expected to deliver business features. So if you remember the definition as a service, what does it mean as a service? In this approach, end-to-end fulfillment of the need, and the need was onboarding, was missing. And domain team needed to handle technical capabilities by themselves instead of focusing on what we actually paid developers to do, which are delivering and operating business features. The situation looked completely different in Alpha Bank, as you probably already foreseen. The domain team in Alpha Bank entering the company had one Jira ticket. It was onboarding ticket. They provide their two things: programming language they will use to build an application, application sizing and business criticality, so how many users, if this is a customer-facing application or not, list of necessary integrations, simple names of the systems which will consume APIs and or provide APIs to, and who will be delivering the application, the names and or emails of the developers who will be building this app. Platform team had such a ticket automated, and in 15 minutes they provide such a team a runtime repository. In this repository, the team found the demo application written in a language they wanted to use building the application. This demo application was deployable up to production. So actually, at the first day, they could done a Hello World deployment. This demo application was connected to observability. This demo application had a database with connectivity to this database, had some sample API exposed. It was reachable by the systems which are going to consume those API, and so on and so on. So after 15 minutes, the domain team were technically able to deploy the Hello World version of the application to the production environment. And after 1 day, they had all the network connectivity to the systems they want to integrate with. So after 1 day, they were ready to go. And the environment and the deployment process they received was already approved by the security. So if they wanted to really release something to the production, the only security testing they were doing was on the business application itself, not the software supply chain. So this was the reason why the time to market for the new business application were 2.5 times better, because we save time and address the cognitive load of waiting. Also, we don't spend time on learning the new tech, configuring the new tech, everything which was present in a beta bank. What is important here is the most domain teams didn't even require their own DevOps engineer in the team. And only R&D, more mature, and data teams, where the runtime was more related to the business logic than in usual application, needed such a setup with the DevOps engineer. This is how we limited the number of DevOps engineers to a dozen, serving almost whole the company working in a platform team. What Alpha Bank did differently, they decided to invest in such a setup. They decided to invest in the platform because they foreseen that this will benefit if the organization scale, if they are going to do a lot of delivery. So if you now look at the cake, we established a clear, you designed it to build it tyrannic boundary between platform team and domain team. This boundary had been defined in operating model between those two teams, and we also defined how platform and domain team works together, defining the services. Onboarding was only one of the services. We had also a dedicated for new integration. We had for new developer onboarding, new test environment if it was needed for the integration, penetration tests, and so on. Everything which we recognized as a cognitive load. What is tricky about platform engineering is that the boundary and definition of the services needs to fit the situation in particular company. This is why you need to analyze the situation first. and then establish the boundary and services. Because what is ideal for one company won't be ideal for the other company. And there can be several boundaries even between the teams, even in one company. So in short, platform engineering done well puts the boundary correctly. Where to put it is the analytical process. So combined forces of managers and engineers working together to define where the boundary actually is. And the boundary depends on many different factors: maturity of the domain teams, there are needs of the domain teams, and scale, if we are going to more focus on operate or deliver the new features, on the timeline, on an SS situation and an SS technology stack, on the licenses sometimes within the business applications, on the architecture of business applications, and so on. And also, once we have this boundary, we also need to design the cooperation between platform and domain team, and define services which fits the need and maturity of stream-aligned teams. So in Alpha Bank, our boundary were somewhere between shared responsibility between deployment and observability. But if you run more mature company, if you run startup, if you run R&D or topics related to AI or even specific software products, what as a service means for you may be different. For you, ordering a pizza maybe needs to be more detailed or more simplified. So in order to build a successful platform, you need to categorize the needs, categorize the teams within the maturity, and then decide the boundaries in form of the operating model and the services, and then build and deploy first version of your platform, ideally reusing as many DevSecOps tools as you can, and repeat this process in a constant continuous delivery loop. You probably already realized that those first mentioned two, categorize the need and design operating model and services, those are not very technology related tasks. It's a job mostly for managers with analytical skills, with the support of DevOps engineers. And in my experience, it's the 80% of overall complexity if we introduce platform engineering. Mostly because my experience tells me that here, most of the technologies and people are already there. Like DevSecOps tools are nothing new in 2024, hiring DevOps engineers as well. So what platform engineering brings to the table is the way we organize those resources. So platform engineering is about 80% of work organization and 20% of changes to be applied on the technology level. So if you remember the beginning of my speech, I said the platform is a system which supports delivery and operations of other systems, the business systems. So the right approach to deliver the platform is exactly the same as we approach the classic software delivery. We need 3 steps, just like classic business application: analysis, delivery, and operations. There is work to be done in each step, both from organizational perspective and technical perspective. In analysis phase, what we do is cognitive load recognition. And based on this, we create operating model and services. My experience tells me that also doing this, the organizational changes in the structure, how the company works, is also changing. So platform is wider topic than just organizing DevOps engineers and DevOps tools. Engineers should also do their analysis. Platform engineers should also do their analysis based on current technology stack and definition of the services from the managers or analysts. There is a platform to be designed to fulfill it, and permission model in DevSecOps tools to be planned, and orchestration layer to be delivered. What is it? We'll cover very soon. Then we go to the delivery phase, where all this plan in analysis phase needs to be implemented to deployed. We do the organizational changes, we implement ticket structure, we implement portal, we implement orchestration in DevSecOps layer, and we implement and advertise, which is super important, the communication channels. So everybody knows that there is a platform in the company. Then we have operational phase, where our platform is live, where we need to monitor if it's going on the right direction. Make sure that the needs of stream-aligned teams are properly addressed and the stream-aligned teams are migrating to the platform without a headache. This is approach to platforms, which I concluded into one of the first, I think, management frameworks around this topic. And I created a course for IT managers so they can successfully deliver the platforms and learn from my 5 years experience in this role, avoiding my mistakes. Till tomorrow, the course is have 20% discount on ITManager code, which is valid only 24 hours from now. And there you will find the whole analysis, delivery, and operations framework detailed, together with a list of my failures and lessons learned. You will find there analytical methods to define platform operating model and services, insight on how to build business case around the platform, how to address this topic in a company on a proper level, because it's not just engineering topic, all together with some ready-to-use templates for the analysis and for platform operating model and service layer design. Okay, so I said that 80% work is organizational and 20% is technical. So let's quickly look at this 20%, because without technology, platform will be another bottleneck, not a solution, but a cognitive load generator. So I recognize 3 architecture layers within internal developer platforms. First is the DevSecOps layer, which is usually present in most of the enterprises, sometimes too present. Platform support the cleaning up and automation here, and we don't have any duplicating capabilities or redundant instances. What platform introduces also are 2 layers on top. In service layer, there are orchestration scripts to be implemented in platform services. For example, if we have onboarding, there will be scripts creating namespaces and so on. And in DevOps interface, a serving layer, we implement the communication method between stream-aligned team and platform team. So stream-aligned team can request the services. It can be Jira, it can be APIs, it can be a dedicated internal developer portal. Ideal situation is where the interface triggers the right scripts in the service layer. So we achieve self-service. So the developers can be fulfilled with the service without the presence of platform team member. Ideal situation because they are unblocked. So now if you think that, okay, platform is something complicated, and do I really need this? Is it worth the effort? Let's calculate it. Imagine you have 10 application teams in organization and each team has 6 developers. Let's say that average salary of the developer is $50 an hour. And let's say that each team is creating 1 application release per month without a platform. Without a platform means that 1 week per release they need to spend on technical organizational configuration. It means different stuff. At the beginning, of course, the whole onboarding, which was present in beta bank, like a bustle running between the company, it takes more than a week. Later on, when we do it, it's just a network configuration, it's just security tests, things which can be limited to even few days. But overall, let's say 1 week per 1 release. If we have such a setup, yearly waste because platform is missing in such a company, which is not very big, is $1.5 million. This is the amount you can build a platform at this amount for such an organization, even less. So we're closing to an end. So let's discuss how we recognize that the platform is a success. As a fan of military history, I've divided the metrics and success measures into 2 categories. Tactical, which are right about the platform. And here you can find things like service fulfillment time, availability, time to fix for the platform, cost of the service fulfillment, everything related closely to the platform. And strategic, which are more about how the platform impacts the whole company, the whole SDLC, like time to market, but for the business applications, not for the platform. How many applications are migrated to the platform? How many DevSecOps tools are outside of the platform team? How many technical tasks are in the developers' backlogs, and so on? Of course, not everything depends on the platform here, but platform should positively impact those metrics. And I personally like to combine those 2 categories together, so I can you always see the bigger picture. Okay, so last question to be asked today, and we can jump to A short Q&A if you want to stay a little bit longer. Do I have a platform in my organization or not? Or even if there is a platform team, are they operating well? So if you feel that you have poor time to market or high cost of applications delivery, maybe it's something to be done with the platform. If you have a lot of people involved, if there is a critical business a bug, especially core IT people, maybe missing the platform. If you have a lot of permission granting tech-related issues and reassigning the tickets between tech teams, also maybe indicator. Long onboarding time for a developer. How much time he needs from or she needs from getting the laptop up to deliver the first version of the application. A lot of the DevSecOps tools, like between many domains. A lot of tech-related tasks in the backlogs of delivery teams. If the team is spending time on configuration instead of delivering application, maybe platform is missing. And if you need a DevOps engineer in each and every team because they won't be able to deliver anything without DevOps engineer, maybe it's worth to think about investing into platform engineering. Okay, thank you for your attention. If you want to stay a little bit longer, it's time for questions, if you have any. I'm here to answer it. So I will go into the chat. Maciej, if you can allow people to ask questions, it would be nice.
Chat, in fact, is open for the question.
Okay.
I have one question, maybe. Do you see? I mean, like based on my current experience, I see one of the reasons for platform engineering is that we not involve analysts as a position in let's say infrastructure team. At least what I see, like what I this what you mentioned is like managerial role. So someone who is someone between management and analyst, yes.
To be honest, I think that my experience tells me that usually two roles are missing in platform team. One is front-end developer, because the back
full stack is not like front-end
or full stack if we introduce backstage, so this role is missing. Also, a developer in platform team gives you the insight on how the software development works, because in many organizations, platforms are being built by the administrators, and usually administrators have not this expertise and experience in business application software delivery lifecycle. So, like this is one thing. And second role is this DevOps analyst. My experience tells me that the usual failure of the platform initiative is because the analysis is missing. So actually, companies are starting with not with the first two, but they jump right into automating the DevSecOps tools and implementation, and they jump into like setting up backstage instance without talking to developers, without talking to platform users, and most of the failures are going to be there, I believe. So yeah, that role is definitely missing. I say that manager can play this role, and if the manager is on a full-time, the manager should play this role of the analyst. If not, then maybe hiring some kind of a person with architecture experience, but business application experience, have some thrive into DevOps engineer role. Maybe such a person can play a role of analyst.